All right, in this video, I'm going to show you the notes and explain the notes for handout 24. I made a video where I was writing all this down, but I lost it, and so I'm just going to basically explain what I have here and kind of show you, and you can write it down and follow along. All right, so we're using Desmos. So sometimes in math, like I explained in class, you have a situation and you want to explain it using an equation so that then you can tell things about the equation, like the best possible scenario, or like in this situation where we're going to basically make an enclosed area, right? And so we want to have the largest area possible with our fencing that we have. So we're basically doing modeling, right? And all this modeling that we're doing, we're making up a model to deal with a situation, and our models are going to be parabolas or quadratics in this situation. All right, so let's get to it. So actually, I think I should stay like this. Sorry. All right, so let's see. So in this first problem, you have 1,200 feet of fencing, right? So you want to enclose a rectangular playground. So think of it like a dog park or something. And you want a little part for the small animals, and you want a bigger one for the bigger dogs, right? You're going to subdivide it into two smaller playgrounds as shown. So determine the length and the width, so basically X and Z, of the largest possible playground. So you have two things going on here in this problem. You have the area, so you want the area to be the biggest, right? But you also have this perimeter to deal with. Now, perimeter, it's not a perimeter in the true sense of the word, because perimeter is really just a distance around it. That's why I put it in quotation marks, because we also have this line right here. So the perimeter is kind of like the amount of fencing that we're going to be using, right? So our perimeter is that we have two X's and we have three Z's. So that is 2x plus 3z. So that perimeter, that's the fencing. So that amount is going to have to equal 1,200. All right, so get that stuff written down up at the top and pause if you need to, but I'm going to move down here. So number one, we labeled all the pieces. We got that. Number two, if you use all the fencing and you sum up all the sides, we're going to write an equation. It has to be equal to 1,200. So we wrote this equal to 1,200. Now, we're going to need to basically calculate the area as well. The area is the length times the width. So my X, whichever I choose that to be, times Z. So I need to get the Z right here. I need to solve this equation for Z so that I have an equation for Z, so that I can do X times Z when I do my area. So to solve this one for Z, I'm going to move the 2x over. So you can see it becomes negative 2x, so 1,200 minus 2x, and we got 3z. And then to get rid of the 3, I divided everything by 3. So you can do it one of two ways. You can divide everything by 3, which leads you to this answer, or you can just divide the whole thing by 3, and it leads you to this result right here. Either way, that's your z value. So that's z based on x, right? So think about it. Like you have 1,200, you use the two x's, and then you need three z's. So that's what this thing is telling you. You have 1,200, take away the two x's, and then divide that by 3 to get each z value. Okay? All right. So now we're going to basically calculate the area. So the area of this rectangle is the length times the width. Okay, length times width. All right, my length is x, so we put x. And my width is z. But remember, z is this. So that's what I put here. So we're going to multiply these together, and we're going to have an equation for our area. So I multiply that out, and we get to here. And so look, that's a parabola. It's a parabola. It has a negative x squared, so it's going to be upside down. Okay, so we're going to take that to Desmos and graph it. So when I take that over to Desmos, and I've typed it in just like it looked, right? And so when you type it in there, you get this like picture over here, and you're like, oh, like I can't see anything. It's supposed to be a parabola. Where's the other side? Well, let me close this off. Oh, crap. Oops. There, I meant to just do that. So I'm going to zoom out until I see the other side, because it's supposed to be an upside down parabola. So I should be able to see the right side of it, because I see the left side. Oh, there's the right side. The problem is I cannot see the height of it. Like I can't see the vertex. I can't see the top of the curve. So we're going to press this little wrench in the top right hand corner, and I need to make my y value higher. So it's right now it's at 798. So I'm going to type in 1,000. And I'm just going to keep adding zeros until like I start to see the curve, and there it is. So now I see it. So I'm going to draw this curve, and we're going to want to know 7 things about it. So 3 of those 7 things are going to be the x-intercepts. So here's one x-intercept, here's the other. And then here is the third thing, the vertex. So 3 points, both x-intercepts and the vertex. So we're going to write those down, and then we'll talk about what they mean. So basically, we have drawn this picture. So I've got my 2 x-intercepts and my high point. All right, so those are 3 of the 7 things you're going to need on the graph. The other things are going to be labels. You have the x and f of x, right? Or a of x, sorry. So that's what this is. A of x is your y value, and x is your input, your domain. All right, so those are the next 2 things. So we got 1, 2, 3, 4, 5. Now the last 2 things are these labels here. So the x's in this problem, they were the width of the play yard, right? So that's going to be the width of the playground, and it's in feet. And then the y values, the a of x, that was the area of the playground. And when you do area, the length times the width, it's feet times feet. So that's how you're getting feet squared. So every time you do area, it's always in like units squared, like centimeters squared, feet squared, meter squared, whatever your units are. Okay, and so let's look at what this means. This means that if I make a playground that the x value is 300, so if this is 300, then that's going to be the largest area that I'm going to get. So 60,000 square feet is the largest area that I have. Okay, and then I want to know the dimensions of the playground. So the dimensions are like the length and the width, just like the dimensions of a room or something like that. Okay, so I know the length is 300. And think about it. If you want to figure out the z value, all you have to do is work with your 1200. So if this is going to be 300 and that's 300, so that makes 600. And so that means I have 600 left from 12. So 600 left divided by 3 lines would be 200 each. So that's how we got this 300 by 200. Now, this little part right here, that means by. And so when you write like a dimension in math or just in life, when you want to say 300 by 200, you use a little x symbol. So, it kind of means times, because if you multiply these, that'll be the area. That's going to be your 60,000, but that's just how you write it. Okay. So another way to find that other number right there is this. Take 300 and you want to know what the z is, right? Well, look, here was the equation for z, right? You can take that 300 and put it right in there, or use this one and put it right there. But when you do 2/3 times 300, the 3 and the 300 are going to cancel out to 100. 100 times 2 is 200. 400 minus 200 is 200. Okay, but I think it's probably also easier to just think about it logically in the picture. All right, so after doing this problem, you know how to do on your homework. You basically know how to do question 2 and question 3. Question 3 is kind of like the one we just did. Question 2 is a little bit easier. You're trying to build a rectangular enclosure along a river. So you don't need a fence right here because the river is going to be your fence. So basically you're going to have 3 sides of a fence. So it's going to look like this. The side parallel to the river is going to be x, and the other 2 sides are going to be z. All right, and that amount of fencing is going to be 800. So once you know that, you go and make your equation for your perimeter down here, and you go to it. Okay, and then you finish your graph and all that. So here we go. All right, so this is kind of the hardest of the 3 types of problems that we're going to do, and that's only because of this little equation that we're about to make right here. So this example talks about making money. So, what we're going to be dealing with is we're going to be selling yearbooks, right? So your yearbooks are $80. You sell 1,000, so 80 times 1,000, that would be $80,000. So that's how much you would make, right? You'd make $80,000 if you sold the yearbooks for $80, okay? And so that right there is called your revenue. Your revenue is not your profit. Your revenue, because that's how much money you're bringing in. Now your profit, you'd have to know how much the books cost from the manufacturer, and then you'd have to take that off and blah, blah, blah. We're not doing profit. We're just doing revenue. Revenue is how much money you're gonna make from this action, okay? All right, so let's read the scenario. It says last year, a high school yearbook sold, the yearbook club sold 1,000 copies, $80 each. This took a survey and found that for each drop of $1 in price, 20 more kids would have bought the book. Okay, so I said, well, if it was a little bit cheaper, I would have bought one. So we're going to figure out what's going on here. We have to come up with an equation for that. So basically, let's just figure out a few. So if you drop to $79, you would go up by 20 people. You drop to 78, you go up by another 20. 77, another 20. 76, you go up another 20. Okay, so what's happening is the number of things that you sell are based on your price, right? So it all starts with 1,000, and you would basically sell more books, 20 more books every time your price goes down $1, right? So here's my equation. I'm going to start with 1,000. I'm going to add 20 people every time my price goes below 80, right? For every dollar that my price is below 80, I'm going to make 20 people. So let's try this a little bit. So that's going to be the hardest part, coming up with an equation. So let's try like 78, right? So if I do 78 here, 80 minus 78, that's 2, because $2 below 80. 2 times 20 is 40, and 40 plus 1,000 is right there. Let's do 76. 80 minus 76, that's 4. 4 times 20 is 80. 80 plus 1,000 is 1080. Okay, so that right there, that's your equation for your number of your books. Now, so that's basically right there. Now you could leave it like this, okay? You can leave that like that, but just because we're here, I'm just going to go ahead and multiply it out. So I'm going to multiply this out, leave my 1,000. This gets me 1,600 minus 20x, all right? And then put this together right here, get this equation. So that's for my number of yearbooks. So we talked about earlier, when you want the revenue, so your revenue, the money that you're bringing in, is going to be the number of the price, how much you're selling a book for, times the number sold, right? So it's going to be this times this. So your revenue is X, which is the number, the price of the yearbooks, times the number that you sell, right? So we're going to take X and we're going to multiply by N of X. Now, I used my finished problem right here. So I did X times that guy right there. But you could have also used this. Like, nobody says you have to clean it up. You're going to put it in Desmos, and Desmos doesn't care. So you could effectively put X, and then you could put this next to it as multiplication, in parentheses, write all that right in there, and just stop and just type that into Desmos. But, I'm just going to clean it up. So I cleaned it up, I multiply this out, and I get my parabola. But again, you don't really have to do that. You could just do, X times 1,000 plus 20, 80 minus X, and make sure you close your parentheses. If you type that into Desmos as your R of X, that's perfectly fine. Okay, so you type that into Desmos, you get your picture good using the little wrench, probably change the height and stuff. And so I'm not going to do that again because I already did it before, but this is a picture I get. I get my 3 points, 1, 2, 3 important points, x-intercepts, and my vertex. And then I label also my axes. This is X, this is R of X, because this is what we were graphing. X is, remember, the price of the yearbook, so the price in dollars. And R of X is my revenue, the amount of money that I make in money. All right, so the yearbook price that's going to generate the greatest revenue, that's this guy right here. This is the price of the yearbook, and it will make me this much money. That's what I want to know, right? I want to charge the price to make my most money. So it turns out like, I feel like, I'm going to charge $80, so I make a lot of money. Well, I wouldn't make as much money as if I sold it for $65, because enough more people would buy it so that the lower price would actually be better. Okay. All right. So then we're going to go ahead and the maximum revenue, 84.5, we got from here. Okay. And this last question, you got to figure it out a little bit. How many people are going to buy the yearbook at that price? Well, look, if you make $84,500 and each book is $65, you could just divide those two numbers and you're going to get 1,300 people bought it. Because you want to know, 65 times what made your 84,000 number, right? So you just divide it and see. Or if you don't want to do that, you could take this $65 and you could put it right in your equation, right? 80 minus 65 is 15. 15 times 20, whatever that is, times, I think it's 300, and then plus 1,000. So that's where we're getting 1,300. Okay. So now that problem is on your homework, like this guy right here. Okay, talking about tickets at a football game. All right, and the last problem. So last problem deals with, it's like a physics type problem. It deals with the path of an object. So like projectile motion is what you call it. So when you throw something, somebody throws a ball or, kicks a soccer ball or something like that, it makes a parabola in the air, right? It rises and it falls, okay? So the equation for this baseball that's being thrown is this right here, okay? That's what you're going to type into Desmos so that you can see these points and everything. And these parts of this equation come from a few places. If you take physics, you know that, negative 9.8 meters per second squared is going to be your gravity. That's going to be like the effect of an object falling, the gravity that pulls it down. That's in meters per second squared, but negative 16 is the one for feet. So negative 16 feet per second squared, that's gravity in feet. Okay. 35 right here is right there. That's where your initial velocity goes in these problems. And then the 6 right here is going to be your initial value. Your 6 is basically going to be, you're going to see on your graph, that's going to be the height at time 0. Because if you plug 0 in for t, these go away and you get 6. So 6 is basically like when I'm releasing the ball. So I throw the ball and my arm is 6 feet in the air, because whatever, it goes above my head. Maybe I'm 5 feet tall and then my arm's above me. Okay. All right. So you graph this in Desmos, you orient your graph, and you get this picture here. So we want 3 points. We got here, here, and here. And look, this time I don't care about this x-intercept over here because it's negative. Time can't be negative, so I don't really care about that. So I want this y-intercept, the vertex, and my other x-intercept. So notice that this equation, time is the input. So t is my input, that's time, and it was mentioned that it was seconds right here. And h of t is my height of the ball. So h of t is the height of the ball, and it's in feet. So get that drawn, and then basically we're just going to interpret all these points. So remember, time 0 is 6. That's when I'm releasing the ball. The ball goes in the air, and this is the highest, and it comes back down at this time. So this is the time it lands back on the ground after 2 seconds and 2.35 seconds. So it lands on the ground, right? And the highest it ever got was at 1.09 seconds. It was 25 feet in the air. Okay. So that's pretty easy. You're just interpreting the picture. And so now you know how to do the very last problem about a volleyball. Pretty much almost the same problem, basically. Okay. All right. That is it. Bye-bye.